Hello, boys and girls. Miss Munoz here. Last set of problems that we're going to solve together. Problems 36 through 40. So, problem 36 here we have the box plots show the target heart rates for men 20 to 40 years old and men 50 to 60 years old, right? Here is like the two box plots. And then it says, which statement is best supported by the information in the box plots? So we're looking for a true statement. So let's look at answer choice A. And then it says the range of the data for men 20 to 40 years old is less than the range of the data for men 50 to 70 years old. So we need to find the range for each of the box plots. The range, you figure it out by subtracting the greatest value minus the least value in the data, which in this case is going to be 80, like for the 20 to 40 years old. And then for the 50 to 70 years old, we have 145 minus, okay, it's not very good, 145 minus the least amount here is 75, and we have a range of 70, right? So the range here is 80 and the range here is 70. So I'm going to substitute those numbers instead of like the description, the data for 20 to 40 years old. Here we have 80, the range, right? And then on the 50 to 70, we have 70. And then I'm going to read the statement again. 80 is less than 70. Nah, that's not true. 80 is greater. Then we have the median of the data for men. 20 to 40 is less than. Okay, let's see. Median is the value inside the box of the interquartile range. So let's go ahead and see. Okay, this is the median for each, right? The median for the 20 to 40 year old man is 130. And then the median for 50 to 70 is 110. So I'm going to read the statement again. 130 is less than 110. Is 130 less than 110? No, of course not. Then it says here the minimum target heart rate for 20 to 40 year man is less than the minimum. The minimum, we're going to look at the minimum value here, right? So I'm going to have here the minimum value for 20 to 40 and the minimum value for 50 to 70. So here is 75. So the minimum value for 20 to 40 years old is 90. And then the minimum value for 50 to 70 is 75. And then I read the statement again. 90 is less than 70. Well, obviously it's not. And that leaves me with the last statement to be true. I hope we didn't do anything wrong. Here it says the interquartile range. Interquartile range means IQR. Or in other words, the size of the box. The box itself is the interquartile range, the range between, Q3 and Q1. So here, at first sight, if we look at this, I see that the interquartile range in 20 to 40 is greater than men 50 to 70, just by looking at the boxes, right? And so here it's saying is greater. So if I want to give a value here, I would say, okay, I go from 110 to 150. So this is a 40, right? And then you're going here from 95 to 125. So this one is a 30, right? The size of the interquartile range. So we say 40 is greater than 30. Indeed. So our correct answer is letter D. There, that's problem 36. Problem 37 requires for you to substitute these values to see which one satisfies the inequality. In other words, here it says which values from this set of numbers satisfy this inequality. So I have an inequality that says negative 1/2 times x plus 3 is greater than or equal to 5. So what we need to do here is substitute these values instead of x and see which one gives us true results. So what I'm going to do here, I'm going to say, okay, the first one is negative 6. I'm going to go negative 1/2 times negative 6, right? Then it says plus, I did substitute the 6 here instead of the x, plus 3 is greater than or equal to 5. And so if you notice here, I have negative times a negative is positive, and then half of 6 is 3. So 3 plus 3 is greater than or equal to 5. And I think it is, no? 6 is greater than or equal to 5. So this one makes it true because for sure 6 is greater than 5. Then let's go ahead and check negative 4, right? So I'm going to substitute it maybe here on the side. I go, okay, negative 1/2. And instead of x, we're going to write the value negative 4. So it's negative 1/2 times negative 4. And then we have plus 3 is greater than or equal to 5. So here I need to think, okay, how much is 1/2 of 4? Is 2. And then negative times a negative is positive. So 2 plus 3 is greater than or equal to 5. And then 2 plus 3 is 5. Well, it's not greater, but definitely, like it says on this line, that means it's equal. 5 is equal to 5. So for sure, this value, negative 4, makes this inequality true. It makes it true, right? So, but I have a feeling that as we approach the smaller values, like negative, the greater values, my bad, they're not going to make this inequality true. Let's see, we use negative 3, right? So instead of x, we're going to substitute with negative 3. So I'm going to solve it here. Negative 1/2 times negative 3 plus 3 is greater than or equal to 5, right? So here I'm substituting negative 3 instead of x. So half of 3 is 1.5, and it's positive. Negative times a negative is positive. Plus 3 is greater than or equal to 5. And if I add 1.5 plus 3, we have 4.5 greater than or equal to 5. And this is definitely not true because 4.5 is not greater nor equal to 5, right? So negative 3 does not make this inequality true. So, and as we will continue to approach into the greater values, definitely will not help us out. So only negative 6 and negative 4 make this inequality true, as you can see here, right? This one, it's already not true. Not true. So we will look for an answer choice that has negative 6 and negative 4. And there you go. That's the answer to problem 37. Then we have problem 38. 38 is asking us about volume, right? It says a ring toss toy is composed of a rectangular prism on the top of a cylinder. The rectangular prism is completely filled with water. The dimensions of the rectangular prism are shown in the diagram. So what I see here is this is like definitely the length of the rectangle. This is the width of the rectangle, and this is the height of the prism, right? And I know you did go over volume of a rectangular prism in 5th grade. We are going to cover that here in 7th grade as well, right? But this is some previous knowledge that could be really helpful right now. So the question here is, what is the volume of the rectangular prism in cubic centimeters? So volume, the formula is length, you know, right? Times width times height. So all I have to do is substitute these numbers. Instead of L, length, I'm going to use 9 centimeters times width, 2 centimeters, times height, which is 15 centimeters. So 9 times 2, I have 18. And then 18 times 15. And volume will be 18 times 15. 5 times 8 is 40. Carry 4. 5 times 1, 5, and 4, 9. This is not a 1, it's a 10. So I put the 0. 1 times 8, 1 times 1. 17. So our volume is 270 cubic centimeters. So we have that, letter B. There you go, problem 38 done. Now let's go over problem 39. Problem 39, it says, a worker uses 450 inches of steel wire to make 300 springs of the same size. At this rate, how many inches of steel wire are needed to make one spring? Right? So this sounds like a proportion to me. It says that 450 inches of steel are needed to make 300 springs, right? And then it says, okay, how many inches will be needed to make only one spring, right? And so here, this is what I'm looking for. I think, okay, for starters, I think we can simplify this. Like I can go, okay, a zero and a zero. It's like I'm dividing by 10, right? So I have 45 and 30. What do I do with 30 to get to 1? Well, I will divide by 30. And then 45 divided by 30, we get 1.5. Here, 45 divided by 30. 30 times 130, remainder 15, decimal, drop a 0, and then we have 5, 150, right? Remainder 0. So it's 1.5 inches for one spring, and the equivalent of 1.5 in a mixed number will be letter J, 1.5 inches per spring, right? And then the last question that we have here is, it says the net of a triangular prism is shown. We have one of the nets. However, we're going to go over this problem just for you to get an idea. It says use a ruler provided to measure the dimensions of the net to the nearest half centimeter. And the question here is, which measurement is closest to the total surface area of the triangular prism in square centimeters? So here you cannot measure it because this is not like the correct scale. So I'm going to give you the dimensions, right? I got them obviously from the answer key. So we have that the distance from here to here is 2.5 centimeters. And from here to here also is 2.5 centimeters. The distance from here to here is 3 centimeters. The height for this triangle is 2 centimeters. And the distance here, right, to here for these triangles is 1 centimeter. So what they're asking us is to find basically the area of every single shape that you see here. They want for us to find the area of each of these triangles, right? They want for us to find the area of this triangle and then the area of this triangle, right? And then we need to find the area of each of these rectangles. And then at the end, well, we add all of these shapes areas together, and that is what they're asking us to find, which is the total surface area of the triangular prism. So the easiest thing to do will be to get the area of, and I don't know, I hope you can visualize it with me here, of this large rectangle that I see here. I see like obviously yes, I do see three little rectangles, but I see a large rectangle right there, and I know that it's 1 centimeter for the width, and for the length here of this large rectangle, I think the length is 2.5 and 2.5 is 5 and 3. The length of this is 8 centimeters, right? So if I want to get the area of that large rectangle, I would say, okay, to get the area of a rectangle, we just multiply length times width, right? So the length is 8, the width is 1. So the area of this large rectangle, the yellow one here, is 8 square centimeters, right? So far I have the area of that large rectangle. Now I need to find the area of a triangle. To find the area of a triangle, right? You can get that in your reference materials, and I'm gonna have to scroll all the way up. That way you can see it, right? We're gonna spend a day going over like areas of triangles. But here, to find the area of a triangle, let me just erase this. We don't need it at this moment. The area of a triangle is right here, area of a triangle. And the formula says area equals 1/2 the base times the height. So I'm going to use this formula, right? Area of a triangle, to find the area of those two little triangles that I have on the figure. So let's see here. I'm going to write the formula. The formula says 1/2 base times height. So the base of the triangle here, I'm going to say, okay, the base is this one, this 3. The base of the triangle, right? So the base is 3 centimeters. I'm just going to write here, the given facts. And then the 2 centimeters is the height of the triangle, which makes a right angle with the base. So the height is 2 centimeters. This is for the triangle. And so to solve it, we're just going to substitute these numbers into the formula. Area equals 1/2 of 3 times 2, right? And so we know how to multiply fractions, no problem. And we can simplify here the 2 on top and the 2 on the bottom, definitely. So the area of one triangle is 1 times 3 times 1 is going to be just 3. But this is the area of one little triangle. We have 2 triangles, correct? So I said, okay, well, 3 plus 3, right? Because there are 2 triangles, 1 and 2. So the area of the triangles is 6 square centimeters. So now I have the area of the triangles, and I have the area of the whole rectangle. So the total surface area will be, well, the addition of 8 plus 6, which will give us 14 square centimeters, making letter B the correct answer choice. So there you have it. We have finished officially with our study guide in preparation for our benchmark or checkpoint test. This test will happen in March 24th, which is the Wednesday after spring break. So please continue to review these notes, the videos, try your best to solve problems, without having to get that much assistance. That way, you start getting more confident and successful acing this test. We will cover the lessons that we have not covered for sure before the start, right? And well, I wish you have a very restful spring break and refreshing and recharging your energies. That way, when we come back, we hit the ground running and we finish this year strong. Stay safe, kiddos, and I will see you when I see you after spring break. Bye bye. Here we go. Let's turn this off.